Okay, this video is the Thermochemistry Part 1 virtual review. So, number 1, A, B, C, and D. You got to say if something is exothermic or endothermic. So, a reaction happening inside of a beaker and the beaker feels cold. Okay, the key thing is on this one is if it feels cold, all right, that means that it's endothermic because you're feeling the beaker, the chemicals are taking the energy out of the beaker, so the beaker's going to feel cold. Whenever a beaker feels cold, it's endothermic. Whenever a chemical reaction is happening inside a beaker and it feels hot, that's exothermic. Okay, when you get a delta H value, if the delta H is a negative value, that's exothermic. All right? If it was a positive value, then it would be endothermic. Okay, when you get a thermochemical equation, you have to look at which side the energy is written on. Remember, everything on the left side is what the chemist puts in. Everything on the right side is what comes out. And so if the energy is going in, it's entering or endothermic. Okay, let's look at this one here. This is what the chemist puts in. This is what comes out. If the energy is coming out, then it's exiting or exothermic. Okay, question 2A. If 14 grams of lithium reacts with excess copper 2 chloride, how many kilojoules are produced? Well, remember that there's an energy to mole ratio, all right? So it's an energy to mole ratio from the balanced equation. So first you have to have a balanced equation, but this one's already balanced for you. So what you're going to do is you're going to take the grams of lithium and you're going to change to moles of lithium. So 1 mole lithium equals roughly 6.9 grams of lithium. And then you're going to do the mole to energy ratio. So look, I have moles lithium here. So I got to look at the equation. So I get for every 2 moles of lithium that react, I'm going to get 330 kilojoules. A big mistake that some people do is they go 14 grams and they change to moles, but they don't write lithium here. So then when they're doing this step down here, they don't know what to look for in the equation. But because this is moles of lithium, you have to have moles of lithium here. You get the number, the mole to energy ratio, you get that from the equation. All right, so now I would just take 14. So if I have my calculator, I'm going to take 14, let's see if I can get my calculator to work, 14 times 330 divided by 6.9 divide again by 2. So I get roughly that equals, if I just go to 3 sig figs, that's going to equal roughly, my calculator says 334.8, but I would just round that to like 330 if I was worried about sig figs, kilojoules. All right? Okay, to make 2,300 kilojoules of energy, how many grams of lithium must be reacted? Well, if you want to make that much energy, remember that there is a mole to energy ratio. So the equation says to make if you were to make react 2 moles of lithium exactly, you would get 330 kilojoules. Notice how I kept the kilojoules diagonal from the kilojoules. But it wants grams lithium, so you would have to change to grams. 1 mole lithium is 6.9 grams lithium. Now remember, whenever we change to grams, it's 1 mole, all right? So if I go 2,300 times 2 times 6.9 divided by 330, I get like 96 grams of lithium. All right, that's that. Okay, now this is number 3 is a specific heat problem, and you're going to want to make a list of metal and water. Why don't you pause the video for a second and make your list a metal list and a water list like I showed you. Okay, so what you'll want to do is you'll want, whenever you're doing calorimetry, you're putting something hot into something cold, you want to make a metal list and you want to make a water list. And the variables are Q, M, C, Ti, TF, change in temperature. So metal, water. Q, M, C, Ti, TF, change in temperature. All right, so the first thing you do is you start reading. The determined specific heat of metal assumed places 200 milliliters of water. Well, remember 1 milliliter equals 1 gram, so that's going to be 200 grams water at 27 degrees Celsius into a calorimeter. And remember the specific heat of water when it's liquid is 4.18 joules per gram degree Celsius. The student adds an 85 gram piece of metal. So 85 gram piece of metal at 100 in the water. The temperature of the water in the calorimeter increases to 28.5. So if the water goes up to 28.5 degrees Celsius, remember that the final temperature, the water warms up, the metal must cool down. Well, the metal stops cooling down when it reaches the temperature of the water when they meet. That's called equilibrium. Okay, what is the specific heat of the metal? So we're looking for C. Okay, so I'm going to calculate the change in temperature. And so 28.5 subtract 27.0, that's going to equal 1.5 degrees Celsius. And all right, let's see here. And then the metal that you're going to have to, I'd probably use a calculator. That's what I'm doing right now. So I'm going to take 28.5, subtract 100, and so I get negative 71.5. So the change in temperature of the metal is negative 71.5 degrees Celsius. All right, now what you want to do first is for the water, you want to do a Q equals MC delta T to figure out how much energy the water gained. So I'm going to put in the mass, 200 grams. There's supposed to be a decimal point there, times the specific heat of water, 4.18 joules per gram degree Celsius, times the temperature change of the water. And if you do that math, so it's just a matter of multiplying, 200 times 4.18 times 1.5, I get that the water gained, it's a positive number, the water gained 12, oops, I don't know what I did there. Don't want that. The water gained 1,254 joules. Well, if the water gained that much, so the water gained 1,254 joules, that means the metal must have lost the same amount. All right? So now we can do the metal. We can take the metal, and to get the specific heat, we're going to do that the specific heat is equal to the energy that it lost divided by the mass times the temperature change of it. So we can plug in the numbers. So negative 1254 joules divided by the mass, 85 grams, times the temperature change of the metal, negative 71.5 degrees Celsius. And so if I do that math, 1254 divided by 85, remember to divide by both numbers on the bottom, divide by 71.5, I get, oh, I don't know what's going on here with my computer. It's changing sizes for some reason. Okay, so I end up getting about 0.2, let's see, I'll go to, looks like about 3 sig figs, so 0.206 degree, not degrees Celsius. That should be joules over grams degrees Celsius would be the unit. So 0.206, technically I guess you should go to 2 sig figs because that's 1.5. So C is equal to 0.21 joules per gram degrees Celsius. Okay, this is part 1 of the video for the front page of the review. So there'll be another video about the back page. That's it.